Okay, in the next series of videos, we'll be looking at the graphs of the trigonometric functions. We'll start by looking at the graph of y equals sine of x and give the main information that you need to know about this particular graph and also the cosine, especially if you're going to sketch these without using a graphing calculator or maybe later on solve equations that involve these two functions. So first, just to make sure here, a little review. We know that pi radians is equal to 180 degrees, and sometimes we leave out the radian and just leave the pi. So if you're dealing with degrees and you don't indicate the degree symbol, then it's in radians. Okay, so if I divide this by pi, I get 1 radian is 57.3 degrees. And then we can go through the process there. Pi over 2 or 180 over 2 is 90 degrees. Pi over 3 is 60 degrees. Pi over 4 is 45 degrees. Pi over 6 is 30 degrees. 3 pi over 2 is 270 degrees. Okay. And of course 2 pi is 360 degrees, and so on. Okay, so let's look at the mode here. We can have radian mode, we can have degree mode. Okay, this one is set to radian, so let me hit the y equals here to get the x graph, and I have y equal to sine of x. And then if I hit the graph on this one, I don't really get a nice graph here. Okay, so let me go back and let's see, let me try this first. I could go to zoom and then try Z trigs. Let me hit 7 here. And that gives me a nicer graph. Okay? But I'm going to go ahead and put this to degrees. We know the relationship right here between radian and degree. So let me put this on degrees. Hit enter here. And then graph. Okay, now it doesn't come. Now this one doesn't come out. So again, I'll go to zoom 7, and there it is. Now we talk about periodic functions. Okay, so the trigonometric functions are periodic. They repeat at a certain interval. Okay, so if we look at the sine function here, I'm going to do a trace here. I'm going to hit the trace key, and so right there at the origin, that's 0 radians or 0 degrees. Okay, so let's trace this. Okay, so you can see there at the top, I get to 90 degrees on the x-axis, and I go up 1 unit. Okay. So at 90 degrees, and if I talk about radians, I would do pi over 2, I get a maximum value. Okay, let's continue. And now, at 180 degrees, or pi radians, the y value is 0. Okay, so I have another x-intercept. I have an x-intercept here at the origin, and one at 180 degrees and 0. So let's continue the trace. Okay, now at 270 degrees, we go down 1 unit. Okay, that's -1. Okay, so as you can see from this, that the sine curve is going to oscillate from 1 to -1. That's how this range comes from. Okay, the y value goes from -1 to 1. So the maximum value of the trig function over its domain is 1, and the minimum value is -1. Okay, continue the trace here. You can see then that at 360 degrees, or 2 pi radians, I have another x-intercept, and then you can see the graph repeats. Okay, so we can say that one period one period of the graph is 2 pi radians. Okay, so from 0 then to 2 pi, or from 0 to 360 in this case, is one period. And then the graph just keeps repeating. Okay. Now we can also say the amplitude of the sine function is defined between the difference. It's the difference of the maximum value and the minimum value. So the maximum value is 1, the minimum value is -1, so 1 minus -1 is 2. And we take half of that. So we say the amplitude of the sine function is 1. So again, another thing to note here is that the graph crosses the x-axis. And again, we can talk about the zeros, okay? Because that's where the y value is 0. So we can talk about the zeros of the sine function occur at, or we can mention the x-intercepts. So at multiples of pi. So at 0, of course, here we're talking about degrees. So again, relate the two. So multiples of pi, and that would be 0, pi, 2 pi, and then we can continue if we wanted to, okay, past that particular period to 3 pi. So at multiples of pi, you have the x-intercepts, okay, x-intercepts. And now if you look at this, at pi over 2, or again 90 degrees, and over here at 3 pi over 2, the graph reaches a high, okay? So we can say then that the odd multiples, that is pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, the graph of the trig function either reaches a maximum value of 1 or a minimum value of -1. Now these things or notes or this info that I'm giving you is going to be convenient, especially if your instructor asks you to graph, say, a trig function without the calculator, okay, and we just sketch the graph. Now keep in mind, it could be different. So it could, instead of y equals sine x, it could be y equal to 2 sine x. And this, instead of just x, this could be 2x. That's going to affect the period. Or it could be something like 2x, parentheses here, 2x minus 3. And then you could even have a number added over here. Okay? So these things are going to affect this right here, this 2 right here is going to be the amplitude. Okay? Because instead of having those values going from -1 to 1, they're going to be different. Okay? And the period is going to be different because the coefficient of the x is going to change. And because we're adding a number over here, that, again, the graph is going to change completely. So the graph could shift vertically. It could shift horizontally. It could be stretched out or could be compressed depending on the values that you have here. Okay? So let's clear this. So that's why here again, the domain basically tells me, okay, what are the permissible replacements for x? Well, x can be any number if we're talking about radians, or x could be any angle, no problems. The range is going to stay between -1 and 1. And in other words, the values of when you plug in a value for x, whether it's radian or an angle in degrees, the value you're going to get is going to be some number between -1 and 1, okay, including the -1 and the 1 if it's this, okay. Now if you have other values over here in front of coefficient of the x, how the sign changes, or this has a 2x over here, this is going to change over here. But that's the standard domain and range for the function. Okay. In the same way, turns out the cosine is going to have the same domain and the same range, because if we look at this, clear this, and let's enter the cosine. And then what I do is zoom 7, Z-trig. There you have it. Okay. So the one period, the main period for the sine function basically went from 0 to 2 pi. Okay, from 0 to 2 pi. So a length of 2 pi. Okay, and that gets repeated. That's what we call the main period. Okay. For the cosine, again, it's going to go from 0 to 2 pi. But you can see that the graph is similar to the sine function. In fact, if we shift the cosine function, or the graph of the cosine function, pi over 2 units, okay, this way, move it over to the right, pi over 2 or 90 degrees, you get the sine function, or the graph of the sine function. So let's do a trace of this one. So you can see that at 0 radians, or 0 degrees, the y value is 1. Okay, so let's continue here. You can see there that at 90 degrees, the y is equal to 0. That's an x-intercept, or a 0 of the graph. Okay. Pi over 2, we get 0. Or 90 degrees, we get 0 to the y value. If we continue the trace, okay, at 180, goes to -1. Okay, so over here at 0, it went to 1. Okay, so again, you can see that's why it's going to have the same range as the sine function. Continue the trace here. Okay, at 270 degrees. Okay, remember here we're dealing with degrees, but that's the same as 3 pi over 2 radians. Okay, I get y equals 0, so I get another intercept. Then I continue. Okay, and then you can see I get at 360, it's going to repeat again. So see, this one's coming down like this, and then it loops, and then it goes up, and then it's going to come down again. So it's going to repeat. So the main period we say is from 0 to 360, or from 0 to 2 pi. So again, it reaches a maximum value again at 2 pi. So again, what we can see here then, if we refer to this as, or discuss this in terms of radians, we can say that the cosine function reaches a maximum or a minimum value at multiples of pi, or multiples of 180. Okay, so we talk about degrees right here. This is 0, okay, radians, okay, radians. I'm sorry, this is 0 radians, and then this one over here is pi radians, and this one right here is 2 pi radians. So again, it reaches a high or a low at 0, pi, 2 pi, and then 3 pi, and so forth. Okay, so at the multiples of pi, it reaches a maximum of 1 or a minimum of -1. Okay. Now the other thing we can look at is, okay, right here has an intercept. Okay. So at pi over 2, the graph crosses the x-axis. Okay. At 3 pi over 2, it crosses the x-axis. At 5 pi over 2, it crosses the x-axis. So we can say then that at multiples of pi over 2, that's pi, 3 pi over 2, 5 pi over 2, 7 pi over 2, and of course we go to the negative side also if we want to, but we're just going to focus on this area right here. At the multiples of pi over 2, the graph of the cosine functions has an x-intercept. Okay, and that again is one of the reasons that we say the range goes from -1 to 1. The domain, there's no restriction in the domain. Domain can be any number. Okay. So if I give you say a regular function like f of x is equal to 1 over x, f of x or y, so I can call this f of x or y. So again, if I wanted to find the domain of this one without looking at the graph, okay, I could do the graph though. The graph basically could look like this. I have a asymptote at x equals 0 and y equals 0. In other words, the x-axis and the y-axis are asymptotes. So you can see by this one right here, the domain is the permissible replacements for x. What are the permissible replacements for x? Well, in this case, x can be any number except 0 because division by 0 is not defined, and that's dictated here from the graph. You can see that. So if I say, okay, the domain then is going to equal to, you can see this thing goes down forever, and it goes up forever, never crosses here. Okay, so it looks like the domain will go from -infinity to 0, union, okay, this is union there, 0 to infinity. Okay. Now, what is the range? Well, from the range, again, you can see from the graph it goes on forever that way, down this way. So from plus infinity to -infinity. So it's going to be the same as this one. So the range or the y value can be any number except 0. Okay. If we were to take this and solve for x, we would get x is equal to 1 over y. So you can see then, okay, that from this right here, y can be any number except 0. Okay, so again we get the same thing. Okay, so this is dealing with domain and ranges, but again, the things you should know, especially if you're going to be sketching the graph of these trig functions without the use of the calculator. Okay, so hope this helps you out. Thanks for watching. We'll see you next week.